Okay, this is question 10 from the 2008 exam 1, so it's a by hand question, and it's an exponential function and it requires us to find the rule and domain of the inverse. So for the inverse we'll need to swap the x and y values. So whenever you see inverse, swap x and y and then make y the subject. So we'll let fx equal to y, so we'll call that all y, and then we'll say instead of y, for the inverse we're going to swap x and y, so y becomes x and e to the power of 2y, take away 1. Okay, so we found the inverse rule. We need to just transform the equation to make y the subject. So move 1 to the other side of the equation, we get x plus 1 equals e to the 2y, and to solve for an exponent we need to change that into log. Okay, so basically what we've got here, the exponent is 2y, so we've got 2y equals log, the base is e, so e goes down here, that's the base, and the number is x plus 1, so that goes here, x plus 1. And then we need to divide both sides by 2, so we end up with divide that by 2 and divide this by 2 is a half, yeah, all divided by 2. So we get the rule for the inverse, which is f negative 1 x equals a half log e to the x plus 1. We also needed to find the domain as well of the inverse function. So looking at the inverse function, the domain, which means the values of x, well, x, you can never have a negative number. Anything to the power of something will always give you a positive number. So what we need to do is the x values that exist in here must always give a positive value. 0 is not acceptable either. Okay, so basically if we said x was x has to be basically greater than negative 1. Okay, so for example, if I put negative 1 in here, I get 0. You can't have 0. It has to be greater than negative 1. Okay, so basically if I put, say, 2 plus 1 is 3, that's okay. If I put minus a half, that's okay as well, because that's going to give us positive a half here. So x, that's the domain. X has to be greater than negative 1. Or if you want, you could write it as the domain is from negative 1 to infinity. Okay. Okay, the next part of the question asks us to sketch the graph of this composite function. It's a composite function. What it's doing is putting the inverse inside the f function. Okay, so let's do that. Let's find out what the rule is for the composite function. So our original function, fx is e to the power of 2x. Well, instead of x, because it's a composite function, we need to put the inverse into x. So substitute x with all of this stuff here. So that's okay. Let's do that. A half log e x plus 1. Okay, and then it's take away 1. Okay, so that's the composite function, and we'll just need to simplify that. So 2 times a half is 1, so that basically cancels that out, and we're left with e to the log e x plus 1. Well, e to the log e, they basically cancel each other out. Okay, so basically we're left with x plus 1. So we've got x plus 1 and then still minus 1 here. So the composite function ends up as x plus 1 minus 1 is 0. Okay, so the composite function is y equals x. Okay, so that's fine. Just make sure that we're going to sketch it over the maximal domain. And if you remember, the domain of a composite function is equal to the domain of the inside bit here. Okay, so basically from minus 1 to infinity is the domain. Okay, so if we mark minus 1 as this point here, and obviously when that's minus 1, x would also be minus 1, y would be minus 1, sorry. That's our starting point here. Remember that it doesn't exist at -1, so we have an open circle, and then the rest of the graph is just a straight line, y equals x. Okay, going through the origin and just continuing on to infinity. Okay, and that's our inverse. So that's basically the solution to that problem. Have a quick look at the assessment report, and for 10A, you can see it's 1.3 out of 2 marks was the total marks for part A, and part B, not done very well, only 0.20 out of 1. A lot of people didn't put that domain in. Okay, so good luck with that.